Hello guys, welcome to my channel. So this is T. Kirtana from SBC. Today we are going to learn about the DMZ networks, what is its purpose and how it is actually made and controlled. DMZ networks understanding the perimeter. A DMZ network acts as a buffer zone between your internal network and the outside world, providing an extra layer of security for sensitive data and application. So this presentation divides into the working of DMZ, exploring its purpose, components, and best practices. Then I have purpose of DMZ networks. We have three purposes of DMZ network. Then protecting internal network, hosting public service, and control access. So how the internal data is protected or internal network is protected from outside world or some threats. So the DMZ acts as a barrier, preventing external threats from accessing your core network and its sensitive data. Then hosting public services. Services exposed to the public like web servers or email servers are placed in the DMZ, minimizing the risk of exposing your internal network. Then controlled access. Traffic flow between the DMZ and the internal network is strictly controlled, preventing unauthorized access to sensitive data. Then I have key components of a DMZ network. There are the four key components, that is firewall. The DMZ firewall acts as a gatekeeper controlling traffic flow between the DMZ and both the internet and internal networks. Then I have Bayesian host. Bayesian host is a hardened server that acts as a gateway for access to the DMZ, providing an additional layer of the security. So this Bayesian host will provide additional layer for the security of the network and the data. Then intrusion detection system, IDS we call actually. The IDS monitors network traffic for malicious activities, alerting administrators to potential threats and facilitating prompt security measures. Then I have demilitarized networks. Then the actual DMZ network is where public facing services reside, segregated from the internal network from enhanced security. Then I have a firewall configuration from a DMZ, inbound rules, outbound rules, and network segmentation and port for forwarding. Then I have inbound rules. Strict inbound rules are essential to prevent unauthorized access to DMZ services from the internet. Only allow specific ports and protocols required for public-facing services. Then I have outbound rules. Outbound rules control traffic from DMZ services to the internal network, limiting access to necessary resources and preventing data breaches. Then I have network segmentation. Separated DMZ services into distinct subnets to isolate them from each other, then minimizing the impact of a security breach on other services. Then I have port forwarding. Configure port forwarding rules to allow be as accessible from the internet with the DMZ services. Then I have advantages of a DMZ network. What are actual advantages? Enhanced security. We have a forward security, then reduced risk. There is a risk will be very reduced, that is the data will not be encrypted or copied or the network will not be disrupted. Then we have even improved control. So there is a improve in control with the outside world and the net uh, privacy network. Then simplified management. The management is very simplified in this. Enhanced security, the DMZ provides an additional layer of defense against external threats, protecting sensitive data and internal network resources. Then reduced risk by isolating public-facing services. A compromise of a DMZ service won't necessarily expose the entire internal network. Then I have improved control. Improved control is what the DMZ allows administrator to restrict access to internal network resources from the DMZ, ensuring data confidentiality. Then simplified management. Managing and updating DMZ services is easier as they are segregated from the internal network, minimizing descriptions. Then I have disadvantages of DMZ also. DMZ networks increased complexity. It is very complicated actually to protect the data. Then performance overhead. There is a huge performance must be taken at the back end. Then security risk. There is a risk of security. The data must be in a secure way. Increased complexity. Setting up and managing a DMZ requires specialized knowledge and expertise, adding complexity to network administrators. Then I have performance overhead. The additional security measures in place for the DMZ can introduce some performance overhead, potentially affecting service response times. Then I have security risk. It is a security risk is there here. Despite the security measures are sophisticated at compromise the robust security. Robust security also will take place here. Then I have typical use cases for a DMZ networks. There are typical uses like web servers, email servers, data servers, or VPN gateways. Web servers, public websites, and web applications are often hosted in a DMZ to protect internal network resource from potential attacks. So this web servers is interrupted or internally kept in a network resource to protect from potential attackers. Then email servers. Email servers responsible for sending and receiving emails are commonly placed in a DMZ for enhanced security and to prevent spam and malware. Then I have database servers. Certain databases, especially those used by public-facing applications, are sometimes hosted in a DMZ to isolate them from the internal network. Then I have VPN gateways. VPN gateways used to provide against the extra DMZ networks. Then I have implementing a secure DMZ networks. We can implement a secure DMZ networks planning, uh, firewall configuration, IDS deployment, then server deployment. Then I have planning. Start by carefully planning the DMZ network topology, identifying the servers to the hosted and their specific security requirements. Then I have firewall configuration. Configure the firewall to control traffic flow between the DMZ and the internet and internal network, implementing strict rules for access. There must be a strict rules for access like password, login, etc. IDS deployment. Deploy an instruction detection system to monitor network traffic for suspicious activity and alert administrators to potential threats. And server deployment is nothing but deploy the servers that will host the public facing service within the DMZ, hardening them against attack and configuring secure access. Then I have monitoring and maintaining a DMZ, security logs, vulnerability, scams, then performance monitoring, then regular updates, security logs. Continuous monitor security logs for suspicious activity, indulging failed login attempts, authorized access attempts, and malicious traffic. Then I have vulnerability scans. Regularly scan the DMZ for vulnerabilities, patching any discovered flaws to prevent exploitation by attackers. Then I have performance monitoring, then regular updates. Performance monitoring is monitor the performance of DMZ services to identify any bottlenecks or performances issues that could affect service availability. Then regular updates keep all DMZ components including firewall detection systems and servers up to latest security patches. Then I have best practices for DMZ networks. Restricted access, network segmentation, and layered security. Minimize the number of internal network resources accessible from the DMZ, limiting the potential damage in case of security bench. And I have network segmentation. Segment the DMZ network into distinct subnet to isolate services from each other, minimizing the impact of a bench on the other services. Then I have layered security, implementing a layered using multiple security combinations. So detection system, even detection system is also